Hello everyone, and welcome to Basic Math Week 2, or APT. I think you'll like this. I hope it'll be a supplement to what you're learning this week. I think it'd be useful for all of you to know the prime numbers under 40. You should know them, all prime numbers under 100 really, but let's start with the prime numbers under 40. A prime number is a number divisible only by itself in 1. 2, 3, 5, and 7 are all the prime numbers less than 10. Notice that 2 is the only even prime number you'll ever see. All the other ones are odd, of course. 11, 13, 17, and 19, 23 and 29, there are only 2 of them between 20 and 30, and there are only 2 of them between 30 and 40. That's a dozen numbers. I'm sure you all can remember those. That'll be useful in this class. Okay, now when can we divide one number by another evenly? There are 4 rules that'll help us do this. When can I divide a number by 2? Well, you can always divide by 2, but when can you divide it evenly without a remainder? That's when it's even, obviously. Maybe that's not obvious, but I'm telling you, if it's even, you can divide by 2. When can you divide by 5? When it ends in 0 or 5. That makes sense. Here's a rule a lot of people don't know. When can you divide by 3? Well, there is a rule for that. And it's when the sum of the digits is a multiple of 3. For example, if you had the number, say, 1, 1, 1, 1, 1, 1, 111,111. Okay, I can add up all the digits there and I'll get a 6. That's a multiple of 3. So I can divide this whole thing by 3. I know that. It comes out to be 37,037. So it does go in evenly. That is a quick, easy rule to remember. Let's do one more rule. When can you divide by 6? Well, anything that's divisible by 6 has to be divisible by 2. So it has to be even. And it has to be divisible by 3, so this rule has to be true. So if both rules are true, if that's true and this is true, you can divide by 3 and it's even, then you can divide by 6. Keep these 3 rules in mind as we go through this. Okay, now let's break a number into its prime factors using the tools that we just learned. We will use the number 96. Okay, is it even? Yeah, it's even. 9 plus 6 is 15. That's a multiple of 3. So we can divide it by 2 and we can divide it by 3. I bet you that means we can divide it by 6. 6 times 16 is 96. Now, let's see. 6 is not prime. We know that. We can break that down to 2 times 3. 16 clearly is even. Divided by 2. I hope you all know that's a perfect square too. You can divide it, it's really 4 times 4, right? All right, let's break down the 4s into 2s. Well, we got a whole lot of 2s. What have we got? 5 2s there and 1 3. So we found out that 96 is 2 to the 5th power times 3, and this is a much more useful way to write the number 96 for our purposes here. Okay. Let's reduce a fraction using prime numbers. Here's a problem right out of this week's lesson. We're going to reduce 18 divided by 24. Now both 18 and 24 are divisible by 6 because they're both even and divisible by 3. You could just divide the top and bottom by 6 and get the right answer. But let's break it down by prime factors. 18 is 2 times 3 squared. 24 is 2 cubed times 3. Writing that together this way, you can see that the 2 divides the 2 cubed, and this leaves you with a 2 squared on the bottom. The 3 will divide into 3 squared and leave you with a 3 squared on top. And 3 over 2 squared is 3/4. Okay. Let's try something else. I want to find the greatest common factor of two really, really big numbers. How about 3,000 and 1,125? Very big numbers. Somebody told you to take the greatest common factor of this, you tell them to jump the lake or something, right? But let's see if we can break it down. 3,000, well, it's certainly divisible by 5, certainly divisible by 10. In fact, it's divisible by 100. Why don't we divide it by 100? 100 is 10 times 10. 30 is 6 times 5. The 10s can be broken down more. The 6 can be broken down more. Got a whole bunch of 2s and 5s and 1 3. That is 3,000. And this is a much more useful number for us for this purpose. 2 cubed times 3 times 5 cubed. 25. Well, we know that's divisible by 5. Well, 225 is divisible by 5. Do it again. 45 is divisible by 5. Do it again. And 9 can be broken down into 3 times 3. Let's write it this way. This is 1,125, and it's much more useful. Now compare this number to this number. We want the greatest common factor, right? Is 2 a common factor? No. Throw that one away. 3 is a common factor. Notice you got a 3 and you got a 3 squared. Grab the one with the lowest exponent. So put a 3 down here in your mind. And notice we got 5 cubed and 5 cubed. The greatest common factor will be 3 times 5 cubed, which is 375. Okay?